And from here, I'm just going to type my x's underneath x1 and my y's underneath y1. So again, it gives you x1 and y1 because you can put in more than one table. So it's just numbering the tables for you, okay? So we're going to type in 0, 2, 6, 9, 12, 13, 15. My kids, if you had me for Math 1, we did this in the calculators last year because we couldn't use Desmos. This is where you did your stat edit, stat calc for Mr. Barr's stuff, okay? So if you had me, you'll know what I'm talking about. If you didn't, it's fine. 12.1, you just weren't as blessed as the others. 13.2, 10.5, and 9.8. All right. So there's my data table. So I want you guys to look at this graph. You're going to hear me talking a lot today, but you'll live. Do these purple points look like they make a perfect parabola? No. And here's why. We're talking about the distance and height of a basketball when shooting a free throw. Okay, well, even if you're great at basketball, like me and Amari, you're not always going to shoot a free throw that's the exact same height or that goes the exact same distance, because sometimes it banks off the backboard, sometimes it goes right in, sometimes you miss it, okay? It happens. So this data is not going to be perfectly consistent in an equation to best fit a graph to try to touch all these points. So I'm going to do y1 because it's got to match the table. And then here's why we do the squiggle. It's called a tilde. I got to find it on my computer. There it is. Okay. So here's why we do the squiggle. There is not going to be any kind of parabola that can completely equal and go through all of those points, is there? Because then it wouldn't be a... I can't make my cursor perfectly go through all those purple points. So that's why we can't use an equal sign, because it's not going to equal, okay? So we're going to use the squiggle because we're estimating. And then I'm going to type in AX1 squared, over arrow to get out, plus bx1 plus c. So that is the equation of a parabola, and you see how Desmos gave you the blue quadratic, the blue parabola that best matches those points, okay? Now, I'm going to move this up just a tiny bit so y'all can see. Do you guys see how down here it gives you an A value, a B value, and a C value? Those are the numbers that you use for your equation. So, for number 1, where it says find the quadratic equation for the relationship, blah, 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 round to 3 decimal places, I'm going to use y equals ax squared plus bx plus c. Remember, you could have also done vertex form, okay? But I'm going to put in the a, b, and c value that the computer gave me. So, this is y equals negative 0.118 x squared. That's the a it gave me if I round it to 3 places. Plus 2.112x. That's the b it gave me if I round it to 3 places. Plus 4.215. So Desmos straight up gave you the equation, okay? Now for number 2, it says using this function, so we're going to use the blue function that Desmos gave us. That's also why I love Desmos, because it color codes. What is the approximate maximum height of the ball? So we're going off of the blue, not the purple, because it says using the function that you got. So off of the blue, this is where y'all will mess up. Y'all will go click on this purple point. I don't care about the purple point. I said based off of the function that you found, which is this equation. So if we look at the blue, that blue quadratic, the maximum height, guys, is not the x. How high it gets is based on the y-axis. So the maximum height that this ball reaches is 13.675 feet. Okay? So that's how you would type in the data in the table to find features. Sound good? All right. I actually don't think I need to do this next one. If you would like to see help on this, let me look at what y'all's homework is on. Make sure I don't need to do this with you. I don't think think I do. So I'm going to skip this one just to save y'all's time because I don't like to take too much of y'all's time. Although some of you probably don't believe me because you think I like to talk and talk and talk. All right, so last example, this one right here. So it says compare this table with the function and it gives us an equation. What is the distance between each of the vertices or each vertex? So basically it wants me to find the vertex of the pink parabola and the vertex of the green one and then find the distance between the two, okay? So if it's okay with y'all, I'm gonna start with the green one because it should be faster to find the vertex of this one because all I have to do is type in the equation. So I'm gonna go to desmos.com, exit out what I had, and I'm gonna type in g of x equals 3x squared. This one we don't do the squiggle, we do an actual equals because they gave me an equation, okay? Minus 12x plus 3. All right, and I'm looking at it says, what is the distance between each vertex, all right? So the vertex here, this vertex reaches down to -9, okay? So the green one, the vertex is at 2, -9, but it reaches down to -9, so that's the important part. That's the minimum value, okay? This problem should have probably said each vertex value, so I'm going to change that for y'all so you know to use the y, all right? Now, we found the green. We're using the y value because it says each vertex value. The value is the y, the x is the time, right? To find the vertex of the pink one, we need to go put that table in Desmos. So again, we're just practicing putting the table in. So I'm going to come down here and I'm going to add a table. Okay, my x's are -1, 0, 1, 2, 3. My y's are 35, 22, 11, 2, -5. All right. Now, if you look at our graph, all it gave us were the points. We need to fit the actual parabola to those points so we can see the U-shaped graph. So I'm going to click a new box, and this is where I'm going to do my equation. So y1 squiggle, ax1 squared, because it's ax squared, over arrow to get out of it, plus bx1 plus c. All right, and I'm going to get rid of this first graph just because we don't need it anymore because we wrote down the point. So now all you have is this one graph, and it's very easy to see that the vertex of the pink is at 6, -14. So I'm going to copy that down. All right, so we're looking at this problem, and we want to know the distance between each vertex value. Remember, the value is the x's. So if I have -14 and I have -9, I want to know the distance between those two numbers, okay? If you think about -14 and -9 on a number line, the distance is just how far away they are, right? So -14 to -9 is just 1, 2, 3, 4, 5 spaces. You also could have gotten that by subtracting -14 and -9, the bigger one minus the smaller one. So -9 is bigger than -14. So -9 minus -14, you would add if you have minus a negative, and you're still going to get 5. So my answer here is 5. That's the distance between each vertex value. Okay? So I've shown you guys how to, I'm looking for my steps. I've shown you how to compare a graph and an equation. I've shown you how to compare a table and an equation. So that means you could definitely do a table and a graph, right? You also have the steps, and we also did an extra practice problem of putting a table in Desmos. So I feel like you should be good. If you're not, get on the Zoom office hours, video chat me. We can talk about it together, okay? Bye, y'all.